Hello, everyone. Thanks for coming. My name is Elin. I work as an Android developer at Spotify in one of our platform and infrastructure teams. And how many of you have worked with modularization? It's quite a few. Cool. So yeah, that's what I'm going to be talking about today. And given that you've all worked with it, you probably know the answer to this question. How hard can it be? It can be very hard. So that's like the TLDR of this talk. It's very hard. It can be very hard. But you know, the longer story, it's more complicated than that. So modularization is a very hot topic. These are some links to some talks and blog posts that have been done on modularization over the last year. There's also been some talks actually during droidCon now. We had Nikita and Boris who talked earlier today about modularization. Ben talked about doing an instant app. Wojtek yesterday was talking about instant apps and app bundles and stuff like that. And this, I think, is absolutely great because they're covering stuff that I will not be talking about in this talk today. I will not be talking about instant apps or dynamic delivery. I will not be talking about tooling or like data or numbers. I will not necessarily be talking about code, actually, because modularization isn't about code. It's just about moving files, like when it gets down to it. But what I will talk to you about is the Spotify modularization journey. And I think, yeah, we're going to talk about why we got started at Spotify with modularization and how we did it, what we've done, and what we've learned. And I guess what I'm hoping that you can get out of my talk, rather than all the other talks that already exist on modularization, is talking about modularization more at scale. But yeah, to get into why we started modularizing at Spotify, to know that, you need to know some history about Android development and mobile development at Spotify. So mobile development at Spotify started around 2009, and since then, it's been growing quite a lot. And Spotify's grown in many different ways. The amount of teams have grown, the amount of developers in those teams have grown, and the amount of features in the app has obviously grown over the years. And what we all know is if you have more features, you will have more code. And if you have more code, it becomes very slow. And this was the main reason why we got started with modularization. And I say reason, it's more that I think build times for us was the reason why we couldn't not do modularization. Because at our scale, our build times were grinding to a halt. And I think had we not started with modularization when we did, hours of build times, I don't know if that, it basically we wouldn't have be able to work. And that's bad. So we decided to, OK, let's do this. We need to modularize. And we got this sort of task force team that started out with modularization. It was 4 or 5 people who just sat down and sort of figured out, like, OK, how the hell do we get through this? Because we need to, in order to not die of boredom and slow build times. And then how they got started initially was we had this core team, we sat down, and also to preface, we did actually not start with just one module. We had 40 modules when we started out. And that was, we already had modules, so some of our basic UI stuff was already modularized from scratch. We had some testing frameworks and stuff like that, and partner SDKs and things that were already in modules. This is about our main monolith module. So yeah, we had this team, and they sat down and they created this goal, which was to get one feature outside of the main app. And this feature was a quite small, seemingly contained app feature that no one had touched in years. It was sort of sitting in a corner somewhere, and that was the goal. We're going to get this outside of the main app. And as a sub-goal, we want to be able to run the unit tests for this feature in under 5 seconds. Then they got started with some upfront work, some very basic tooling. So this was like, we created a script to create, like, set up a module and create build Gradle files and add it to the settings Gradle file. And just like, you give it a name and then you have a module. Just basic things like that. And then we also aligned on the basic structure. And this can be a picture. Wow, that's really shit contrast. Anyways, this can be, if you have many different modules, they might look like this. And this is, everyone likes bubbles. The structure we went on is our main app. So app is the main module. I'm going to refer to it as app, but it's the monolith module. But we basically saw that as like, the big thing that we wanted to pull stuff out of. And then under that, we had features, we had common code, and we had libraries. And now, it doesn't seem like you can see, but those down there are still bubbles. And I guess my point with this is we didn't make just 4 modules and have everything in 4 modules, because that doesn't help anyone. What we did instead is the features, common, libs, those are more categories for the modules that we did end up pulling up. So our feature modules, that's stuff like end-user features. So search, radio, your library, stuff like that. Common code is stuff that is common code that we share in Spotify, but it's sort of, it's still Spotify stuff. So we have some, UI components, sharing. I have radio here again, because radio for us, we have a radio feature, but then you can start a radio from anywhere in the app. So radio is a feature, but there's also common code about radio, which is used in many different ways. So that's structured in 2 ways. And then the libraries, those are things like very basic stuff, like HTTP, like logging, like something that, and the reason why we're separating common and libs is common is stuff that is common to Spotify. Libs could be open sourced, technically. Like, it could be any third-party thing. It's not app-specific. So if you want to build more apps in the future, we can still share code through the libraries, but not through the common code. And I mean, we do have another app called Spotify for Artists, and they use some of the code. So we do have shared code in the libraries, just not in the common. So there's also a common like a set of common modules for that app. But whatever, that's the main structure that we set up on. And having done that, we started pulling out everything that we needed to make this one feature work that we wanted to pull out of the main app. We also sent an email saying, hey, we're going to modularize. We're probably going to break stuff. We're sorry. We're going to buy you cake if we break master. Yeah, it's just a nice thing to do. So then we said, OK, we got the team. We got the time. We have the PMs on our side, and we're allowed to do this. Let's try it. And pulling stuff out initially, it doesn't always go that well. You move some files, and you're like, oh, look, it's all nice, and there's no squiggly lines anywhere, and then you try to compile or run in it, and yeah, it's a struggle. So then we tried it again, and we tried it again. And then after a while, it did actually compile, and we did manage to get that one feature out. And the sort of side goal that we had on running unit tests in less than 5 seconds, that was sort of like, we'll pull it out and see if it's possible, and it was. We didn't even have to do anything. So yeah, if anyone were to use that feature and like do more development on it, they could use TDD and not have to wait for like 3 minutes for unit test to run. So through this trial and error in the beginning phase, we came up with this process. And I like talking about process through pseudocode algorithms. So I'm going to go with that. So the first thing you want to do is you want to analyze dependencies of anything that you want to move. We have this scale for dependencies, from frictionless to massive friction. Where frictionless, that's classes that you can just move them. They have no dependencies to anything. If you move them up, they still work. And then we have a scale of slight friction to more friction, where you have a class which depends on a class that's frictionless to move. Or you depend on a class that depends on another class, and that in turn depends on a class that's frictionless to move. So there's sort of, an infinite scale of things between more friction and massive friction. But the massive friction, that's like the main source of any spaghetti code in the world. In our case, one of those is main activity, which is, that started out, I'm sure it was very small at one point. It's not. It basically knows about everything that's going on in the entire app. There's basically no way in hell that would ever not live in the main app module. So yeah, that's a skill. So when you've analyzed your dependencies and you know, OK, this is the dependencies, then you go a few number of ways. If it has no dependencies, you just move it. If it has, remember tests. We have a lot of abandoned tests where we've moved out code, and then we forgot about the tests because they never show up when you analyze the dependencies, and then they get sad. I mean, they're still in the app module, so they still run, but it's nice to have code at the same place. Yeah, if you have simple dependencies, you can just break those dependencies. And simple dependencies here could be something like you're depending on a class, which is like a utility class. And I mean, it's nice with, don't repeat yourself and having multiple codes over the same things, but like, you could probably inline that, and it wouldn't be that big of a deal. Other simple dependencies could be, you might have a dependency on something because you use it as a parameter, but maybe you just send that through to somewhere else, which actually needs the thing. And then you could just maybe switch that parameter to something else. Or just use something else, or do something else. Maybe the code is old, and you can just use a new API or something. So then you break the dependency, and then you move on with your life. If you get into the complex dependencies, then you need to spend a lot more time. So then you basically need to spend a lot more time doing the refactoring, or you could try doing dependency inversion. And I'm going to talk a little bit more about that later. And if you're successful with breaking your complex dependencies, that's great. But probably you won't be successful. And one thing we did was we introduced this just very simple annotation called modularization to do, where we just put that in the code base where we ran into a wall and we couldn't do anything else. We added a modularization to do, and then the reason for it, and then that makes it just very easy in the code base to just keep track of where we need to do stuff, and then revisit that. Like a few months down the line, maybe we've already modularized the bigger dependency that we couldn't move because of. But I mean, it's sad. You spend a lot of time, so you might stop quietly in the corner before moving on with your life. Because, the main reason and the main lesson that we learned really early on in the process is modularization takes time, and you need to be patient with modularization. But like I said, we managed to get that first feature out. We managed to get more and more features out. We pulled out more and more code in order to just, make the app as small as possible. We did have a time in the beginning where it was just like anything, just like, let's get it out here, just standing with shovels. And we would just keep doing this, and we were keeping metrics of all of this, and we were just seeing, like, we're moving so much code, but it's not getting smaller. What's happening? Oh, right, we're still shipping features. That's right. They're still adding stuff. So it's, it's tough. So then we're like, hey, can't you just add your code outside of the main app instead? Because then the main app doesn't get bigger. But they couldn't because we hadn't modularized this one API yet. Or like this one thing yet, because that's still in the main app. So unless you move that, we can't do anything at all. And that's also started got us thinking, so that's not really the case. Maybe you can't move your code immediately or create it in another place immediately, but you can write it as if you had it in a module. Because if you write your code as if it's in a module, if you then put it in a module, it will be a lot easier. So this leads to best practices. And some of the best practices that we developed and talked about throughout this process, I'm going to share with you now. So one of them is sort of, don't repeat yourself, removing dead code and increasing reuse. And my main point here is this, I was kind of touching on it, and it's, you're probably doing too much in your code. And you can probably do it in a more organized way if you think about it as, like, what things am I actually doing? I'm probably talking to a backend somewhere to get some data or doing something like that. And that's often code that is repeated, and you do it in maybe different ways, in different features, or in different places of your code. But what you could do instead is to have one API for this is how we do HTTP calls. And then that implementation can be the same and shared, and that logic doesn't have to live everywhere in the code. Another one, which I touched on, is avoid parameter dependencies. So an example for us is we have a feature flagging system that allows us to do A/B testing and gradual rollouts and stuff like that. And what we have to check that is we have this flags object. And we do a lot of A/B testing, which means that flags exist basically everywhere. And it exists in classes that don't really care about flags, or they're not using them, but it needs to be there because somewhere someone's using them. And this is what I was talking about, that we're using these flag objects to just check if something should be on and off. And instead of sending flags all over the place, we can just send this as a Boolean. And then we don't have dependencies anymore. Also makes the code a lot more readable, because rather than seeing flags absolutely everywhere, you have Booleans going like, should this button be green or not? That's just easier to read. And that sort of ties into dependency injection as well. And having dependency injection means that rather than passing around flags because something somewhere needs it, if you're using dependency injection, you can just inject flags where you actually need the flag and where you want to do that check, and not just have it all over the code base. And structure your code. And I realized I rewrote this. I had this as like change the codes, like the structure of your files and whatever. And then I changed it, and I realized that this is how should you structure your code. Basically, in any way, like having structure is better than not having a structure. And having a structure that's sort of similar across features is good. And that doesn't really matter if you're structuring it, like you have UI in one folder and models in one folder and helpers in one folder. It doesn't really matter if you have that or something else. But if it is consistent across features, that makes it more, it sort of helps out along the way. It sort of ties into the stuff I was talking about with having clear APIs for the kind of stuff that you're doing, and sort of knowing what you're doing in your code. Because if you structure it in like UI here, and then HTTP here, and then this here, then you might see that, oh, we're doing a lot of custom HTTP logic where we could just use this more simpler interface over here instead, and not have to do all of this ourselves. Avoid using utility classes and static methods. And this sort of ties in again to the parameter dependencies, because at least at Spotify, we had a lot of utility classes and a lot of methods. And what happened with those is, because they're static, obviously, and then you just send in all of the parameters, just all of them. And then maybe something changed in the utility, maybe someone introduced an A/B test and something needed to change. So then all of a sudden, everything everywhere needs flags all of a sudden. And yeah, again, just having objects instead, like helper objects that inject these things that might not be required for everything everywhere to use, but this helper class needs to know about flags. Then you can just create an object, inject the things you do need, and have the parameters be just the things that actually is needed from the thing that is using the helper. And then solid principles. And solid principles, I hope most of you know about them. I'm going to run through them. This is our TLDR version of them. Don't do a lot of things in one class. Design the API so that a class can be used and extended without being modified. Don't let implementations of the sim interface behave differently. Don't design big interfaces. And depend on abstractions, not on implementations. And this last one, which is dependency inversion, this has helped us immensely with modularization. And yeah, basically what it is instead of having your class directly depend on or use a method of another class somewhere, you put an interface in between. And this is very helpful in those examples where you have massive friction to be able to move whatever you're using. So for instance, if you're, in our case, if we have anything that relies or depends on the main app, or the main activity, instead of trying to move the main activity, we just make our code dependent on one interface, which could be like navigate to home or navigate, like, often it can be navigation, but it could be anything. And then you just have a simple interface which has no dependencies whatsoever, and then you depend on that. And then if you're using dependency injection, you can bind the actual implementation of it, which might be something like main activity or just a class that uses main activity. And then you bind that, so you're injecting the interface, you have no idea about main activity, but under the hood, it's still calling main activity. So what have we actually done up until this point? So modularization for us started around just over a year ago. And since then, we've moved a lot. So I don't know if I mentioned metrics, but we were collecting metrics all throughout our modularization phase. And the reason the graph is sort of smooth at one point is we don't have a lot of data points for that. Because we didn't need to, because we weren't changing anything. But I think you can basically see where we started modularization, which was around there. I don't know if this is visible at all. But around, beginning of 2017. And this is the period I was talking about where you can see, and at that point, the main app module around that stagnant point there was around 600,000 lines of code. And yeah, you can see that stagnating out, but you can also see the amount of code in the app growing like crazy. But the main app is still stagnant. And that was the bit where we were just shoveling out water of the sinking ship, and then feature developers sort of just pouring in more and more and more. And then something that's interesting with this is at the end of 2017, you can see the main app module starting to quite slope and actually decrease properly for the first times. And that was basically when we in the modularization team stopped working on modularization. So this was when we got to a point where we've modularized as much things as possible. It's now on you, the feature developers, to move out your stuff. And at that point, we've gotten to a place where they could do that. So we got people to do it, and now it's down to, it's actually below 300,000 lines of code right now. It's almost 290,000 lines of code in our monolith module still, which is basically back to when we were 3 years ago in 2015. So that's the journey, that's the graph to show our journey, but it's still very painful. I'm going to show you one more graph. And in this graph, the black line at the bottom, that's the red line here. So that's the total lines of app in our code base. Does anyone have a guess of what this green line is? This is our files. This green line is the lines of code of our files that we have. And we have 25 million lines of our file code. And this is, yeah, we have around 400 modules at this point, slightly over 400 and growing. We have over 14,000 R files. And the main reason for this is if you have a module, you have an R file. If you have another module, you have an R file. If you depend on that module, you have 3 R files, because this module will have its R file, and that will have its R file, but this will have an R file of that module as well. And this is something that Gradle are aware of and they're trying to work on and improve for us. It's not a problem in Bazel or Buck, but we're not using those, so it's painful. So yeah, let's talk about build times. And now there was a talk earlier today, and they went into a lot more numbers about build times with modularization. But basically, if you have a smaller module, it's faster to build and compile incrementally. But the bottleneck in your build times will always be the size of your main app module. And now there's, you have stuff like Bazel and Buck, which are other build systems. Bazel is built by Google, Buck is built and maintained by Facebook. And Bazel and Buck are a lot better at handling builds when it comes to a modularized code base, given that you don't have big modules. So I had a colleague, actually, who tried out Buck using OKBuck at Spotify, and the build times for the modules became stupidly slow, like 2-3 seconds. But then the main app was like 15 minutes. So it's we have a ways to go. So yeah, I'm going to move on to what's the biggest lessons and the biggest takeaways that we've learned throughout this over a year-long process. And I kind of like this quote, it's hard to see the forest for all the trees. It kind of relates to, there's this idea called the broken window theorem. You may have heard of it, which is if you have an old building and you have if you have no broken windows, you will not have more broken windows. But if you have one broken window, all of a sudden you'll have like 20 broken windows because there's already one and they're not fixing it, so we can just break everything else. And why I like this and why I bring it up talking about modularization is that it sort of goes hand in hand with having a big module and all the code at one place. You can't really see all the tech debt you have and all the spaghetti code you have. And you can't really tell if you're introducing code that increases the build time by 10 seconds. If you have a build time that's already like minutes long, maybe you won't even notice that. But if you're introducing that in a module where the build time is 10 seconds, and then you're adding 10 seconds, then all of a sudden it's double, like that's 200%. Or 100%. So if you're in that place, it's easier to see when problems pop up. And that's how I see modularization. I see modularization as a tool to get your code base and your code to be healthier and to make it easier to know what dependencies you have or what the code quality is. It's a chance to tackle your tech debt. Like I was talking about with the best practices, is because everything is, small and encapsulated, you can't really have tech debt in the sense of, complex dependencies and whatever, because you can't have those because you're in modules. Or you can, but it's easier not to have them. And I also see modularization as a chance to get to know your code base. And again, this is what I was talking about with getting to know what kind of stuff you actually do in your code base. And knowing what utilities you use and knowing what things are in your feature codes and whether or not that stuff is specific to the feature itself or the piece of code that is doing stuff, or if it's stuff like, technically, if there was a nice API somewhere, I would use that, but there's not, so I'm going to build it myself. And then that happens, in 10 different places in the code base, and then all of a sudden you have a lot more code than you need to have. If that is in modules, it's sort of easier to spot those, and it's easier to think about nicer APIs. And there's this Yelp article or blog post that they posted very recently about how they did modularization at Yelp. And I thought it was interesting, especially this first sentence. Single modules are easier to deal with. There are no complex dependency graphs to account for. And I thought it was interesting, and I chose to revise it, because I think single modules appear to be easier to deal with. Because, yeah, they don't have a complex dependency graph, expressed in build Gradle files, but the dependencies are still there. The dependencies are still there between the different codes, but they're hidden because everything is in this main module. And yeah, that ties into this module thing. If you have things in modules, you know about the complexity of your code base in a completely different way. So yeah, some last wrap-up words of wisdom. if you're going to start doing modularization, or if you're thinking about it, or if you're doing it already. Investing in some upfront tooling, like having a script for creating modules, doing dependency versioning, like having dependency versions for external third-party libraries in like one central place, and not have that like copy-pasted in build Gradle files all over the code base, and then those getting out of sync. Have it in one place. Also, static analysis for realizing when you've forgotten resources files or stuff like that. Like, oh, I accidentally left things behind in the main app. And remember to move your tests. And don't change anything as you go. And this is, like, you know, you go into your code base and you see a file and you want to move it, and you look at the code and it's like, oh, I could refactor this a little bit, and like, it's kind of old code. Don't do it. If you want to get modularization done, focus on the task. Do not clean up as you go. Don't do anything. Don't even change the package structure if you don't want to. Just move it out, get it out of there, focus on the task at hand, add to-dos, add it to the backlog to go back and revisit it, but do not do it as you go. You will lose yourself, and you'll never end up where you want to be. Inventory your app. Again, this ties back to just knowing what kind of stuff should probably be in modules rather than scattered around in different feature codes. It can just help you to reduce the size of the modules when you already have them. And then also collect metrics, because graphs are fun. And then maybe you can go to conferences and do cool presentations with cool graphs and stuff. So I'm going to circle back to this initial question, modularization. How hard can it be? It can be very difficult. And I'm seeing it as sort of software development. How hard can that be? It can also be very difficult. You can make it easier, you can make it hard. If you follow best practices and you structure your code in clean ways and you have nice APIs and all the good stuff, it can be easy. It can be a lovely experience to do software development. Or you can accidentally turn everything into a huge ball of spaghetti, and then your life is terrible. And yeah, I'm just going to leave you with this. So Oddly Satisfying is the channel name of our modularization Slack channel, where we do modularization support. And it's basically doing modularization. It's stressful, it's tedious at times, it's very painful, but in ways it's oddly satisfying. You move out stuff, and then you hit a dead end, and then you cry in a corner for a bit. But then you revisit it like a few weeks later when someone's moved something else, and then it's like, oh, look, I can move this now, and I don't have to worry about it. And after the while, so yeah, you don't refactor stuff as you're going along, but then you do. You come back to it, and then you have all this nice, clean code, and it's just a few classes, and you can go through them, and everything is nice and readable, and you can clean it, and it's just lovely. Thank you for listening. And I don't know if we have time for questions.
Well, yeah, we have time for questions. So please, everyone, use your last chance. Wow, tons of questions. Yes, please come here and walk to the mic, and I'll get the second one for you. Or you come over there as well. And everyone else, if you want to leave, please try to be mindful of the others that still want to listen. So be silent. Thank you.
Hi. My name is Julio. I work at SoundCloud. And first, I want to thank you very much for the talk, which I think was one of the best talk of the conference up to this point. The last talk also. So I'm very curious about, like, after 400 modules you said, I'm curious about two things. How is your team organized? Like, how many developers you have in general, and how many are working on modularization specifically, or if everyone is working on modularization? And then number two is, what do you think, or what's your advice for the base module? What should be there?
OK, well, the first one, we have over 100 monthly active contributors to our Android code base. And we're organized in over 60 teams in 5 different cities around the world. We have New York, Boston, London, Stockholm and Gothenburg. So it's a lot of people, and yeah, the modularization team, when we were starting out, it started with 3 or 4, or 4 or 5, and then it grew, so we were 8 or 9 at the initial points. But then as we've gone, it's more like teams are modularizing what they own. Like they're modularizing their own code. As for the other one with the base module, actually, like I said, I won't be talking about instant apps because we don't have instant apps. We don't have a base module. So I have no idea. I would actually like to know myself. Yeah.
Thank you.
Hi. Thanks for the awesome talk. One concern I also have in my project, where I have about 20 Gradle modules, is the r.java files as well. So one small note, I've watched the talk on Google I/O this year by the Android build system team, and they announced that they are working on it. So hopefully one day that won't be such an issue like now it is. And I have a question regarding the domain layer, or the model, like the plain model objects. For instance, you have a song model. Do you share it among the other modules? Is it separate? Is it moved to some kind of a, I don't know, lib model or something like that module, or do you have your own models per every module, and you have to reassign all the data when passing this object through other modules?
Yeah. So yeah, we have actually great contact with the Gradle team, so we actually know about it as well, and we are hoping that they will do it soon. As for your other question, I'm so tired. I already forgot about it. It was
about the module.
Oh yeah,
models,
models.
right?
Yeah, sorry. Should go home soon. Yeah, with the models, it depends. We have some modules that are definitely shared between different features, and those we have in some libraries, or yeah, in common shared code. But there's also cases where a feature actually has their own models because they're not really sharing it. So in that case, it goes into that module.
Okay, thanks.
Hello, I'm Mario from N26. My question was about static analysis. You mentioned it. Are you using any libraries out there, or what kind of tool are you using for static analysis to kind of check that while modularizing something, you just did something, for example?
Yeah, so we're using lint, PMD, find bugs, check style. Those are the main ones. We also have one that we've built ourselves, which is called difflint, which is lint only on the stuff that you've changed. The main thing there is lint will find all the unused resources and complain about that, and it does complain a lot. And then one thing that I found, which I think it was find bugs, which, so the thing, when you modularize stuff, it can build and run completely fine in some cases, but then at some point it just breaks down and you have no idea why. So we had this thing where a lot of just really strange problems that popped up when we moved files came up through our CI, and a lot of that was actually caught by find bugs that said that, oh, something can't compile. And it made absolutely no sense because the file it was complaining about actually existed, but not something that was dependent on that. So that helped in knowing that something's not right here, but it didn't really help with pointing out exactly what that was. I think if there was more tooling for figuring these things, like we created a document with the most common, if you get this thing, it actually means this. So we had this translator for all the errors that we got through build errors. But yeah, tooling could be very helpful if it existed.
Okay. And the last question.
Hi. Question. Okay. First, in your features model, do you have also the activity and the Android stuff? So you manage with Dagger Android to do the dependency injection in the modules? And
I can, so a lot of our features are actually fragment-based. So the fragments we can move out, but we can have activities outside. But then, yeah, with the activity components, that gets a little bit hairy. Yeah.
Okay, because I solved it with Coin, but Ricardo from SoundCloud told me that Dagger Android apparently does it. One more question. Resources, like the strings, do you have them in the main module? Because I try to put the strings in their own module, but the localization team kind of wanted to kill me because, a million different strings file.
Yeah. So we do have one main strings module, and that has translations, and we set up our translation scripts. We're using SmartLing, and we've set all of that up for that specific module. But we also have some strings that are actually in the modules themselves. If they have strings that are, they only exist for their own use, because the general strings file, it's a lot of strings. That file is very, very long. If you can avoid being in it, it's nice. So then people have their own strings and their own translations within their own modules.
So you wire the translation system to every single module?
Yeah, we have a script that helps out with it.
Perfect. Thank you.
Okay, so thank you. I know there are still some questions left, and I hope, Elin, you have a couple of minutes for private questions afterwards.
Yes, I also have stickers.
And stickers? Wow, okay. Thank you, everyone, for staying until the end.
Thank you.